Hey everyone, welcome back to The Explainer. Today, we're going to completely flip how you look at a tool that is probably already sitting right there in your tech stack. Most dev teams just think of Redis as this simple, traditional cache. But when it comes to modern Retrieval-Augmented Generation, or RAG systems, it is so much more. Our goal today is to show you exactly how Redis operates as a really powerful semantic engine that can completely transform your AI applications. All right, let's dive right into this architecture flow. I want you to really look at this, because right now, honestly, most modern AI architectures are just bleeding money, like literally setting it on fire. Every single time a user asks a question, standard systems jump straight into the heavy lifting. You know the drill, generating new embeddings, searching a vector database, and then paying those premium token costs for an LLM to generate a brand new answer. And they do this over and over and over again, even for slight variations of the exact same question. It is a massive, massive drain on computing power, and more importantly, your budget. But look right there in the center, Redis. We are moving way beyond the old school key value caching you're used to. See how it sits right at the front as a semantic layer? When a user asks a question, Redis intercepts it. If it finds a semantically similar question, boom, it returns the answer instantly. You completely bypass the LLM. This structural shift right here, this is exactly how you slash your RAG costs, making your whole system faster, smarter, and incredibly cost-effective. So, how do we get to that ultimate state of extreme cost efficiency? Well, here is our roadmap. First, we'll hit the RAG optimization problem, then the limits of traditional caching, followed by the semantic cache solution. After that, we'll look at Redis as a vector database, rethinking your architecture, and finally, exactly how much money this is going to save you. All right, part one, the RAG optimization problem. So think about the friction that happens when scaling these RAG apps. Take a look at these two prompts. On one side, how do I reset my password? And on the other, I forgot my login credentials. How can I access my account again? Now, as humans, we instantly get that these mean the exact same thing, right? They both just want a password reset link. But to a basic naive system, they look like two entirely different languages. Which brings us to part two, the limits of traditional caching. If you slap a traditional, dumb cache in front of those two questions we just looked at, it totally misses the shared intent. It treats them as totally separate requests. Just look at this cascade of wasted resources. Because the exact text string didn't match perfectly, your system does two embedding generations, runs two separate vector searches, and fires off two expensive LLM calls, just to spit out the exact same response twice. You're hit with higher latency and literally double the cost for zero added value. It's just brutally inefficient. Okay, moving on to part three. Enter the semantic cache. This is the real game changer, a cache that actually matches by meaning. Let's walk through this workflow. Instead of running that whole clunky pipeline, Redis steps up. Step one, using vector search, it detects that this new question means the same thing as one it's already seen. Step two, it instantly returns the cached answer. And step three, this is the big one, folks. You completely skip the expensive LLM call. Redis intercepts the whole thing and bypasses that pricey pipeline entirely. The immediate operational wins here are huge. I mean, look at these impacts. You get millisecond latency, which your users are going to absolutely love. But in cloud architecture, remember, technical speed is a direct catalyst for financial savings. Since you're skipping the LLM, you are massively reducing token costs and cutting down on embedding API usage. Plus, your system handles heavy load way better because you aren't bottlenecking at the LLM generation phase anymore. Part four, Redis as a vector database. Actually, we can push this even further. Redis has this sort of dual threat capability that goes way beyond just being a speedy caching layer. It actually stores embeddings and performs similarity searches directly. So for small to medium RAG systems, you might not even need a separate heavy vector database. Redis can single-handedly manage the caching and the vector search. It's natively supported, super lightweight, and surprisingly powerful. Which leads to part five, rethinking your architecture. So what does this actually look like in a production-grade setup? This flow perfectly maps out the pattern. Follow along from the user query. First stop, the Redis semantic cache. If there's a match, a hit, boom, we return the cached answer. Done. Only on a miss do we actually route down to a dedicated vector DB, like Qdrant or pgvector, grab the docs and make the LLM do its thing. But check out that step at the bottom. You take that freshly generated, expensive response, and you store it right back into the Redis semantic cache. So next time, it's a guaranteed hit. Storing that response back into Redis completely closes the loop. Your system literally gets smarter and more efficient over time. The architectural wins are undeniable here. Way faster responses, way lower infrastructure costs, drastically fewer LLM calls, and obviously a much better user experience overall. Finally, part 6, slashing your RAG costs. Let's get down to the bottom line, the actual financial payoff of setting this up. Look at this massive token reduction metric. That giant red bar, that's your high cost running a standard REG pipeline without a semantic cache, sending every single query straight to the LLM. Now look at the little green bar. That's your cost with the Redis semantic cache. We're talking a typical reduction of 50 to 80%, or even more, in LLM costs. Let me be totally clear here. If you're skipping semantic caching in your AI apps today, you are actively burning your IT budget. I want you to really let this quote sink in for a second. The biggest optimization in RAG isn't always choosing a better LLM. Sometimes it's simply avoiding unnecessary LLM calls altogether. That right there is the core lesson of this explainer. Sometimes the absolute smartest AI optimization you can do is just doing less repetitive work. So I'm going to leave you with a question to take back to your engineering teams. How are you actually using Redis in your AI applications today? Are you treating it like a dinosaur, just using it for basic caching? Or are you ready to upgrade your stack, turn on semantic caching,